Hi, my name is Ryan Moon. Today I'm going to talk to you about how you can apply some 21st century teaching strategies into your Algebra 1 math classroom. This is a facilitation plan, but it also discusses some of the program goals that I'm doing right now at the Wilkes University. What we're going to use is Barbie bungee jumping to collect some data. So this is the basic setup here. Students will use a Barbie and some rubber bands in order to measure the amount of distance that the Barbie drops. It is a student-centered approach. Helps them apply some linear data, collect and apply in order to solve a real-world problem. The students will collect the data on their own and make their scatter plot. They will create a line of fit for that data that will allow them to have an equation that would model it. And then they will use this equation to predict the number of rubber bands required for Barbie to have a thrilling jump, and I define that as being a jump that gets her as close to the floor or the bottom without hitting it. And we're going to go into the gymnasium and off the back of the bleachers drop Barbie from that distance. So those are the basic learning objectives. We have our resources listed there. You're going to need tape measures or meter sticks. I like to use tape measures when we do the actual the culminating activity in the gym. You need probably about a dozen Barbies. I use partners with this activity because it makes the most sense to have one person who drops the Barbie and the other person to read it. And if you have more students in a team than that, I just feel like the communication can be a little bit of a barrier. You need rubber bands. Try to keep them all consistent. Whatever rubber bands one team uses, they use the same rubber band throughout. Computers with Microsoft, so we can use Excel. And I have some resources for you also, like the lab report and some rubrics and things like that. So I've pretty much given you the overview already. The students will be entering the data into Excel, creating a scatter plot, and then they can use Excel to create their equation for the line of fit. The conceptual theme throughout this unit is collecting two variable data, recognizing two variable data that is linear, and using it to find slope and write an equation of the line. Specifically here, we're trying to use this equation to predict future results. By the end of this lesson, students should be able to identify linear data, whether it's linear or not, create a linear equation, and then use it to predict. I do see some potential roadblocks over the last couple of years when I've done this activity. Students sometimes find it difficult to determine what they should put down for zero rubber bands. So if they don't have a rubber band, how far would Barbie drop? And the answer is all the way to the floor, but we don't really want that. So I asked them to determine what they are, what all their other data would be with one rubber band and all the way out to like 10 rubber bands, let's just say. And then at the end they'll have to make an assumption about what they think that data point should look like, in hopes that they would say that it's supposed to be just the height of the Barbie. Another potential issue could be the actual data collection process itself. You would have to be very accurate, and usually what I try to get them to understand is that they can collect this data with one rubber band, two rubber bands, three rubber bands, but they don't have to just do one single drop. They could do many drops at one rubber band until they get a sense of what the average of this would be, and so on and so forth, so they can be as accurate as possible. The assessments, each team, each pair of students will be given a lab report to complete. They'll also be expected to print their data display from Excel. Their grade is going to be a combination of 4 scores. I'll discuss them a little bit more in depth. I'll use a rubric to assess their lab report and the data display. They will have a self-assessment and a peer assessment also. And the last part of their grade would be their accuracy of which they fall within when they drop Barbie off of the back of the bleachers. If they're within one rubber band plus or minus, I would give them 100% for that portion of their grade, and then it just drops by 5% from there on out if they are off by more rubber bands than that. Some ongoing assessments and progress monitoring. I'll always use daily bell ringers with the classroom transponders to collect some data. And I want to make sure that the students understand how to calculate slope, how to write an equation of the line, and using that equation, can they use it to predict future results, future data points. I also like to use our online classroom environment for discussion posts. Use that usually as a ticket out the door. The last 10 minutes of class, the students will be assigned to respond to a question regarding their understanding of the concepts at that particular point. And that's something that oftentimes I have to watch the kids and maybe halfway through the lesson figure out exactly what that prompt is going to look like. My plans to help advanced learners next year, I haven't done this yet, but I've played around with some of the ideas with two variable data here, not being a linear situation. If we do the weight of Barbie with respect to the distance drop for a specific number of rubber bands, it's going to appear nonlinear, and then that would allow us to, my advanced learners, to discuss a different function type that we could use, our either Excel or the TI-84, to write the equation for it in quadratic mode. Here's the student lab report, and you can see I have this 25% of the unit grade. And there's the rubric for the lab report that I will use to grade it, along with their printout of their data. And the self-reflection and the peer assessment, you can see this is worth 25% total, 12.5 each. And there's the 50% category there, being the most accurate as possible with respect to that culminating activity in the gym. So program goals right now, there's 4 of them that we're working with mostly, and starts with student-centered. I totally feel like this is a cooperative learning environment. It's non-lecture based, it's totally inquiry based. The students are learning and doing things on their own throughout the data collection and entering the information into Excel, and doing the predictions. It's a hands-on activity. There's no way around doing it. You have to do it. I like to use that language a lot. I like my kids actually doing things. If they're sitting there passively in a traditional environment, you're just telling them what to do. Chances are it goes in one ear and out the other. So this is something they can't fake. Using information, that's the 3rd program goal so far, and they're using the data that they gather. They might have to research a little bit about about how to find the equation for the line of fit in Excel, and then they're going to test their predictions. They're using that information to predict, and then they'll have to maybe come back and modify the equation. My role in this, I will facilitate discussions online, and also in the classroom. I'm really not doing a whole lot of direct instruction. The first 10 minutes of class, the students have the bell ringers and the transponders. I might have some individuals where I have to remediate and have some conversations with, but it's really about the kids and where they are with respect to their mastery of the content and their development of understanding linear functions. So that's my presentation for Barbie bungee jumping. I hope you like the facilitation plan, and you could use this in your classroom.